All right, welcome back, friends, to section 5.5. Today we're going to talk again about graphing linear functions, but we're going to add one little twist in here, one little spritz of lemon to kind of spice things up. So let's jump right into it. First of all, this whole chapter we've been talking about how to graph linear functions. So I've shown you a few ways to do this. We've talked about giving you this function y equals 2x plus 1. Last video we talked about how the 2 here represents the slope and the plus 1 represents our y-intercept, so we could easily graph this function. Graphing this as a table, we can see that in a table we are given values of x and y, and then if I give you values of x, you can simply plug these values in here to get values of y, and vice versa. In this last point, I can plug in 11 for y and solve for x. And graphically, we talked about how the horizontal axis represents the x-axis, so it shows us all the x values, and the up and down axis, known as the y-axis, shows us all the y values. And then we can take each of these points and plot them on the graph, and that gives me a pair of x and y, and it shows me how those two things are related to each other overall. Well, we're going to throw a little twist into this, and here's this twist. Okay, instead of writing y equals 2x plus 1, I'm going to show you a new notation known as function notation. Okay, function notation looks like this. F parentheses x. This does not stand for f times x, but this is read f of x. So this is how you would read this. What do you think the f stands for? Okay, well, the f, all we're talking about here are different types of functions. So this f, sorry, I didn't mean to write the equal sign there, but this f really represents function. Okay, so this is telling me that this is a function of x. So what do we replace f of x with? Well, f of x, we are really going to replace our variable of y. Y and f of x represent the same thing. Y and f of x both represent what's called the output. Okay, so instead of y, we're simply going to replace this, ran out of space there, I'm sorry. We're simply going to replace this with f of x. So if you look at our equation, for example, we are no longer going to write y equals 2x plus 1, but we're going to say f of x equals 2x plus 1. In our table, we have x and f of x. And graphically, we can say x, and then my y-axis would be known as f of x. So really, f of x is the same thing as y. What it's saying here, f of x, is that I'm going to have all these different values for x, and I want to know what is the function for each of these values of x. Okay, so when I say, for example, if x is 0, here's how you're going to be able to write this. If x is 0, I'm simply going to write this as f of 0. Okay, now what does that mean, f of 0? Well, instead of the x, notice, instead of writing the f of x, I'm writing f of 0. So what this tells me is simply to take in my equation, wherever I see x, I'm going to plug in that value of 0. So f of 0, wherever I see x, I'm going to replace it with a 0. Okay? That is not a 6, by the way. It kind of looks like a 6 here, but that's a 0. So now what I can do is I can simply evaluate this. Well, 2 times 0 is 0, plus 1 is going to give me 1. So I know that that's going to equal 1. Okay, I can do the same thing here. F of 1, what does that mean? Well, it's simply going to take any value of x, and any x, I'm going to replace it with 1. So that's going to give me 2 times 1, which is 2, plus 1 is going to give me 3. Bada bing, bada boom. Same thing if I say f of 2. Okay, I want to know what is the value of the function when x is equal to 2. Basically asking you what's my output when x is 2. Again, same thing as y. What I'm going to do is I'm going to write 2 times 2. Again, wherever I see x, I'm going to replace it with that value of 2. And then I'm going to simplify. So 2 times 2 is 4, plus 1 is going to equal 5. Okay, so that's going to give me 5. So all this is just a different type of notation that represents the same thing as y. This is our fancy, sassy notation to represent any function, and not just linear functions, but describes any function in general. Okay, so what if I see here this? I see that, oh, my last one, my f of x is equal to 11. In my equation, I see that my f of x is equal to 11. Well, remember what we did before. This 11 really represents the value of y. So where do I plug this into my equation? Well, I know f of x is 11. So how I'm going to plug this one is I'm going to say 11 is equal to 2x plus 1. So it's a similar idea to knowing when to plug in for x and when to plug in for y. Again, all we're using here is just a brand new notation called function notation. So to solve for x in this case, I would have to go ahead and solve this equation. So this is a little practice on solving equations. I would need to subtract 1 here from both sides and get 10. And then I have 2x equals 10, divide by 2, and I'm going to have x equals 5. So I know that this value is going to be 5 for x. And it's the same idea here. Now that I have this table, I can simply plot this table on the graph. Okay? It's the same idea here. I could take each of these points and I can plot it, but I want to talk to you now instead too of how do we actually graph this equation. Well, this equation, yes, even though it doesn't say y equals 2x plus 1, just remember f of x and y are the same thing. We're just replacing y with a new notation. But how would I graph this? Remember here, my slope is 2, my y-intercept is 1. How do I graph this? Well, I'm going to start at 1, and then I'm going to simply go up 2 over 1, up 2 over 1, up 2 over 1. I can go in the opposite order, remember, by going down 2, left 1, down 2, left 1, and so on and so on. I'll just draw a few points, and then I have my line between those two, or between all those points to draw my linear function. Could have plotted the table as well, but here's the idea, folks. All I'm doing is giving you a brand new notation. Some of you seem pretty confident, or will seem pretty confident at graphing equations, but once I throw this f of x into the mix, some of you are like a robot splashed with water and things start to go haywire. So it's just a brand new type of notation that I want you to get used to that we'll use for all types of functions. Okay, so let's get used to using this notation. So here I have the function. It's a linear function. F of x equals 3x minus 4. Okay, so what I want you to do is to evaluate each of these. So the first one says evaluate f of 3. So again, I'm going to read this as f of 3. It's basically saying what is the function when x is equal to 3. So when I say f of 3, I'm simply going to take my equation, and wherever I see x, I'm going to replace it with a 3. So I have 3 times 3 minus 4, and then the rest is simplifying. 3 times 3 is 9, minus 4 is 5. So I know that f of 3, that's a 5 there, not a 3. Whoopsie daisies. Uh-oh. Here we go. Sorry about that. We got f of 3 equals 5. So that would be my answer. And that's how I'm going to write it too. I'm basically going to say the function when x is equal to 3 is going to be equal to 5. Next one, f of 2. Again, I want to know when x is equal to negative 2. What is the function? So f of negative 2 is simply going to equal 3 times negative 2, whoopsies, minus 4. Okay, now I'm multiplying these two again. I'm going to have negative 6 minus 4. I'm subtracting from a negative. I'm going to combine those two and get negative 10. So I know f of negative 2 is simply equal to negative 10. Again, when you look at these two things, my answers now for 5 and negative 10, remember this is going to represent what y is. This is going to represent what y is. In the 3, this is telling me x, and the negative 2 is telling me x. So it's just, again, telling you a value of x and y, but they're just written differently. Again, we're still pairing them together. It just looks a little different. All right, this next example is what happens if I give you a variable in here. So this one says f parentheses m. We were going to read that as f of m. So just like before, what I'm saying is that x is going to equal m. What the heck does that mean? Well, it doesn't really matter here. I'm just trying to get you the point, to get you the idea. When you see this notation, all it tells you to do is to take your function. So I got f of x, and I'm going to plug in m. So I have f of m is going to equal 3 times m minus 4. What's that going to give me? Well, f of m is going to equal 3m minus 4. And that's simply it. Let me look at that and say, what the heck was the point there? Again, it's just the idea. This notation is simply just telling you to plug in for x and then solve for y. All right, now, this notation, notice how it's a little different. I'm telling you that f of x is equal to 20. So in our function here, f of x, you're given f of x equals 3x minus 4. Notice that I'm not saying f of 20, but I'm saying f of x is 20. So in this case, f of x is right here in the equation. What I'm going to do is take 20 and plug it in for f of x. I'm not going to say f of 20, f of 20, but I'm going to say 20 equals 3x minus 4. Basically, I'm saying in this case that y is equal to 20. What is x? Okay, that's simply what I'm asking you to do. And now this is just a simple equation that you should be able to solve at this point. So in this case, I would add 4 to both sides, and I get 24 equals 3x. Then I can divide by 3 on both sides and get x is equal to 8. Okay, so what this would mean now, x is equal to 8, here's how I'd want you to write the answer. If x is 8, what I would say is that f of 8 equals 20. So we're always going to express our answers now in this new function notation. This function notation would be the same thing as saying x is 8, y is 20. It's also an ordered pair. Okay? So be able to solve for these different things in function notation, whether you're solving for x or solving for y. All right, put this together now and do an entire example. So now the function is f of x equals negative 2x plus 5. Again, with this notation, it's the same thing as saying y equals negative 2x plus 5. So I know it's a new notation, but it means the same thing, okay? So know that this function tells us the same thing here. So what I want you to do is be able to take this function in one, fill out a table, and be able to graph it, okay? So let's start by filling out the table. So just the same idea. When I see that x is equal to 5, the way I'm going to see this is that I want to know what is f of 5. So f of 5 is going to equal negative 2 times 5 plus 5. Again, every time I see x, I'm going to replace it. What's that going to get me? Well, negative 2 times 5 is negative 10. Add 5 to that, you're going to get negative 5. So I know when x is 5, f of x, or f of 5, is going to be negative 5. Next one, I could do f of 8. So f of 8, whoopsie daisies here, is going to equal negative 2 times 8 plus 5. Negative 2 times 8 is going to be negative 16. Plus 5 is going to equal negative 11. Very good, very good, very good. Next one, f of negative 2. Again, I'm plugging in for x. I'm going to have negative 2 times negative 2 plus 5. Negative 2 times negative 2 is positive 4. Plus 5 would equal 9. So notice I'm just giving you numbers that jump around just on purpose. And in the last one, we have f of x is 15. So I'm going to write that down. F of x is equal to 15. Well, what's f of x? F of x is negative 2x plus 5 equals 15. Okay, so that last one, I'm telling you that y is 15, solve for x. So now I can simply solve this equation, subtract 5 from both sides first, and I'm going to get negative 2x equals 15 minus 5 is 10. Divide by negative 2, and that's going to give me x is equal to negative 5. So I know that when x is negative 5, that y is 15. Okay, so just solving for the opposite there. Okay, so being able to fill out a table, next thing I want you to be able to do is graph this function. Okay, so graphing this function, you can do it multiple ways. You could take your table. Okay, you could take and plot your table. I also want to show you this, that if you have the function f of x equals negative 2x plus 5, this is just any ordinary linear function. So this right here is your slope, and that's your y-intercept. So you know that your slope is negative 2, which again you can put as negative 2 over 1, and you know your slope is going to be, your y-intercept is going to be 5. So even though, yes, you fill out this table, you can still graph this new notation the same way. You just got to know that the x-axis is here, and f of x is going to be plotted as the y. So graphing this, I can start as plus 5, so 1, 2, 3, 4, 5 would be, oopsie, that's a little off. And then I'm going to go down 2, right 1. My slope is negative. And I'm going to plot these points throughout. And then I can plot just a few points, draw the line between them, and there's my function. So again, be able to take this function notation, understand how to fill out a table, and then understand graphing is just like we did in section 5.4. All right, so now just to get you used to this notation still, we're all this lesson just focusing on this notation. But let's say I give you this random graph. Okay, this graph beyond the scope of this class, I'll give you that, is what's called a piecewise function. You don't need to know that, but notice how it has like 3 different parts to it. You have this kind of curve, this horizontal line, and then a line that we are familiar with from this lesson, or from this chapter, I'm sorry. So this is known as piecewise function because you got all these different things within it, but nevertheless, here's what I want you to be able to understand. If I give you function notation, how do you read this on a graph? Okay, so if I say f of 4 equals what, I'm basically saying, when I say f of 4, I want to know what is y, so y equals what when x equals 4. I'll leave that extra equal sign in there. So y equals what when x equals 4? So this, again, remember saying that x is 4, so there's x, what's y? Well, if I look at my graph, well, when x is 4, when I go over here, I look at my y, oh boy, my y is 3. So that's basically describing that point right there. So f of 4 is simply equal to 3. Same idea. F of 0, again, this is telling me x is 0. Well, when x is 0, that's right there. What is y? Oof, y is 1. So notice it's just simply reading graphs. Okay, so f of negative 1, again, I'm going to look when x is negative 1, what is y? Ooh, this one is also 1. Okay, when x is 2, so 1, 2. What is y? Ah, I see that this is 2. Last 2 here, sorry, f of negative 3. So f of negative 3, it's saying when x is negative 3, what is y? When I go back negative 3, ooh, that means it crosses right at that point right here. So that means this y is going to be 0. It doesn't move up or down at all. And in the last one, what do you think this means? F of x equals negative 3. Well, notice in this one, I don't know x. I'm not giving you x, but this is telling me y. So it's saying when y is equal to negative 3, what is x going to equal? Interesting. So now I look, okay, when y is negative 3, oh, there's negative 3 for y. Let's see, where does my graph go? Oh, I can see over here there's going to be a point. So I know that point. What's my x value? I know that my x is negative 4. So I'm going to write this now, that f of negative 4 would equal negative 3. I'm going to write this in good function notation that my x goes in the parentheses and my y is on the outside, and that would be my answer. So with this example, I'm just simply asking you to be able to read a graph, but you're reading a graph in this new notation. All right, let's apply this now. This notation a lot is applied to real life problems, especially with business, because business, when they make money and things like that, trying to sell things, usually they can kind of fit an equation or a function to what they're doing. So here, let's say we have, let's say that this is a diaper company. That's why I got a little baby there on the bottom. This is a diaper company. They're selling the diapers to babies. So let's say a certain diaper company makes money, determined by the function P of U. Get it? P of U? P of U, PU? Stinky? Diaper? No? I thought maybe you guys would find that funny. I thought it was hilarious. But let's say P of U equals 1 over 4 U to the second power minus 2U. Holy cow. What the heck does this function mean? Well, this is something we may look at in second semester, but you can ignore it for now. But this is just the idea. P, what do you think this stands for? Well, down here it says P stands for the profit. Okay? And what does U stand for? Well, U stands for the units of incense sold. So a diaper company is selling incense. That's what makes things smell good, because we got stinky PU diapers. Incense are going to make them smell nice. So this is a function describing the profit we're making from the number of units we're selling. So determining the number of units we sell, we're going to figure out what profit we had. Okay? So first thing, when I say read the notation, that's kind of what I'm saying right now. When I see P of U, okay, P of U, what does that stand for? It tells me really the profit based on the units sold. Sorry about my handwriting, kiddies. Oh my gosh, it's terrible. Okay, talk about PU. Okay, but my profit's going to tell me or be based off the number of units I sell. Okay, so let's say I give you what is P of 8. Okay, so if I say find P of 8, again, P of 8, what are you going to do? P of 8, I'm going to take that 8 and I'm going to plug it in to the function wherever I see U. Not see me, but see U. Ooh, Jesus, I'm a funny guy today. So I'm going to plug 8 wherever I see U. And now I'm just going to simplify. Okay, now, how do we simplify this? This goes back to the very first chapter we did. Well, we're going to start with order of operations. We're going to start exponents first here. So I have 8 to the second power. So that's 1/4 times 8 to the second power. Remember, is 8 times 8, which is 64. Minus 2 times 8. Oh my gosh, what are we doing here? Well, 2 times 8, well, now we have two multiplication problems, 1/4 and 2 times 8. 1/4 times 64, that is 16. Might have to use a calculator there. And 2 times 8 is 16. Oh, great. So what's 16 minus 16? That's 0. So what does this mean? What does P of 8 mean? Well, what I found here is that, oops, not F, my fault here. What I found here, let me draw it in red, is that P of 8 equals 10. Well, there's no point of this notation. What does this mean? What does P of 8 equals 10? What does P of 8 equals 10? Now, why did I write 10, people? What is up with Big Dog today? Ay, ay, ay. P of 8 equals 0. So what does P of 8 equals 0 mean? Well, remember, the 8 is U, so U is equal to 8. What is that? 8 units. That means I sold 8 units, and I sold that P, my profit, is going to be $0. So if I sell 8 units, I'm not making any profit. So as a company, what do I need to know? Well, I need to know that I need to sell more than 8 units to figure out that I'm going to make a profit. If I sell 8 units or even less than 8 units, I know right there that I'm not going to make a profit there. Okay, so 8 units, there's no money sold. So I got to make sure I sell more than that amount. Okay, now let's say I give you this. What does P of U equal 86,000 mean? Well, what does this mean in my function? I would have to say 86,000 equals 1/4 U squared. My handwriting is just awful today. Minus 2U. Okay, now you look at this. How the heck do you solve this? I don't expect you to be able to solve this. This is beyond what we know right now. But all this is saying is that, what does this mean? Well, this right here is my profit. So if my profit is $86,000, right, I'm basically asking you to tell me, what are the units sold? Okay, so in this case, I'm giving you the profit. I want to know what are the units sold. So this function notation is stuff that we use and a lot of people use in everyday life. Again, it's just a different notation to understand y and x. All right, so if you have any questions, I know that you're trying to figure out how to all that graphing stuff, and I kind of threw an extra little curveball into the mix today. It's okay. If you have any questions, make sure you write them down, bring them to class. Otherwise, good luck in your practice. Peace out, kiddies. Big Dog's out. Leaving you with a little Puff Daddy today.
What y'all wanna do? Wanna be ballers, shot callers, brawlers, who be dipping in the bins with the spoilers, on the low from the Jake and the Taurus, trying to get my hands on some grants like Horace, yeah, living the raw deal. Course meal, spaghetti, fettuccine, and
Peace out, kiddies.